Okay, so we should be live. Hope everyone can hear me. Okay. Okay, the setup is ready. So, hello everybody, welcome to the CNCF Turing meetup. It's a long time we haven't met, but we succeeded in organizing a brand new session of meetups. And let me remind you that we will still be online for a few episodes again because the situation is improving, but not so quick to meet again. As I already said, this gave us the possibility to have a wider audience from all over the world and also speakers from all over the world. The CNCF is the Cloud Native Computing Foundation, and is in general it takes care of technologies in the cloud like Kubernetes, Containerd, and Prometheus. There is this huge picture of CNCF. Here in this meetup, that is based in Italy, in Torino, we are trying to focus on what's going on, what's new in this big landscape. We will have some, let's say, monthly events. We will try, me and Gianluca, to try to schedule something like that. Tonight, it is for us a great night because we will talk back about containers, and we will have Cobus Bernard from South Africa, from AWS, and let me introduce him. Hi, Cobus, how are you doing?
I'm doing fine, Sergio. How are you?
I'm fine. I'm happy to have you here, and we take the chance to host on this stage because otherwise having you in Italy wouldn't be so easy. So we already had a small chat with Cobus earlier, and we know that online meetings sometimes apparently are tiring us because staying in front of the PC all the day and then for the meetup is not like pizza and beer we used to have in presence. But on the other side, Cobus knows this topic very well. So tonight he will try to focus on hands-on, and he will try to show us something very practical, some demo, and demo gods are with you, Cobus. So I leave you the stage and you can go on. And let me just remind people that two things. The first is that if you have any topic to suggest, or any person willing to speak at the meetup, we are open to listen and to learn something new. And the other thing is about the talk of tonight. Feel free to post a question in the YouTube chat because I will try to address them to Cobus as soon as possible, even in the meanwhile. So we will try to have something more interactive tonight. So Cobus, the stage is yours, and let's go. I'll see you later.
Awesome. Thanks, Sergio. So, thanks everyone for joining us here today. As Sergio mentioned, we're all tired of just looking at a screen, and especially as a presenter, I'm tired of just, talking at the wall and hoping there's someone listening. So please, if you have a question as we go along, pop it in the chat. We can go down some rabbit holes, look at things, poke around. Like Sergio said, this is a hands-on talk. I'm going to show you my configuration, show you my Terraform, everything set up. We're going to spin up one of the containers that I usually have running that I just quickly killed off now for this session. And what I'm going to do first is I've got a couple of slides just to quickly go through and give you some background for some extra visual aids in terms of instead of me just standing here waving my hands and looking silly. So let me quickly pop open my slides and then we can get the party started. Cool. Swap, and I just need to quickly adjust this so I can actually still see the questions. Okay, cool. So I can still see the questions as they come in, so we can handle them when we see them come by. So first off, this is going to be a talk about how I run containers here at home for myself. I've currently got one little microserver. I'll show you some photos of it later. Used to have a whole cluster of them running, but basically just an easy, convenient way to run things at home. And being someone who's got a DevOps background and loves automation and also loves AWS, I decided, well, let me see how much of this I can automate and how simple I can actually make it. But before we get into the talk tonight, I normally have issues when I speak to Alex about this. So come on. There we go. I need to apologize because I know I'm speaking to a predominantly Italian audience, and I do eat pineapple on pizza. So if you do want to leave the session now, I will understand, and I apologize. So, agenda. I'm first going to take you through how it started and the whole history, because I've been running this setup at home, running multiple services probably since about, I think, 2013, 2012-ish is when I first started actually spinning things up at home with little microservers. So I'm going to take you through the entire progression and how we ended up with what I feel is the simplest setup at the moment here at home. Then I'm going to show you my traffic configuration that I use to actually do the reverse proxying, as well as using Let's Encrypt to generate my Ssl certificates for all the internal services. And then the fun part. Once I've showed you the happy path and how it just works perfectly and beautifully, I'm going to show you what went wrong along the way and what I learned, because there were a couple of things and gotchas that caught me a little bit off guard here and there, assumptions I had, etc. So it's basically just, let me show you what the issues are. And then what we're going to do is we're going to switch over to my terminal, and I'll show you how to spin up a container. We'll dig into a couple of the Terraform files into the console as well to show you the configs, and then we'll play around with that. So just quickly kicking off, a little bit about me. I am a senior developer advocate at AWS. And before I joined AWS, I was a developer for 15 years and an AWS customer for 8 years. And I am based out of Cape Town, South Africa, and that is the region code for the region that was launched in Cape Town, which makes me super happy because we get to play around. And then the other fun fact here is that is actually my roof. It's a giant Space Invader on the roof, and it's not painted on. We actually swapped out the tiles to make it that way. Awesome. So now, the progression of my setup at home. The first thing that I did way back when I got my first server and decided I want to run things is do it the old sysadmin route, which is SSH to the box, install the packages I need, configure them, and it was all good. It kind of worked. There was a little bit of issue because things kept configuring over each other. I had issues with Apache and getting the web server to serve everything properly, but it worked. It wasn't too bad. Then I had a life-changing moment. I discovered these little machines. They are called HP microservers N40Ls. Now, they're a bit dated by now, but I have one or two running at home with a couple of things, but it is this lovely little small box. You can see those 4 slots in there are 3.5-inch hard drives, and they're also low power. My one typically, if it wasn't really doing anything, would idle about 20 or 30 watts. So when I learned of these things, I immediately went to look for them secondhand, and I managed to scrounge up 3 of them. So I decided, well, instead of having an old desktop running things, let's go and actually spin up a cluster, because, clusters are cool. Everybody needs a cluster at home, don't they? And at this point in my life, I had learned a nice little tool called Chef. So obviously, what did I do? I went and used my golden hammer on it, and I said, I'm going to set everything up with Chef. I was also using it very actively at work at that point in time. So we went from a very manually set up, no containers on an old desktop setup, to a Chef managed setup, still without containers. And this was just to install the apps, configure them, run them. It was a little bit easier in the sense that if I made a mistake, I could fix it, but still, it was a lot of work for a little server at home. I spent hours on this, but luckily I also spent hours at work configuring things with Chef, so that was all good. Then what happened is I started playing around with containers, and my first experience with containers was actually running a production cluster with Mesos and Marathon. I think Mesos rebranded to D2IQ, I think. But basically, it's a way to run a distributed cluster to run containers or other workloads that you have, just executable tasks. The challenge with that, however, is that under the hood, Mesos uses Zookeeper to keep the state and keep track of what tasks are running where. And if Zookeeper in a cluster mode is unhappy, things go sideways very quickly. And what happened is that we in South Africa have frequent power failures. And that meant that sometimes the servers, if I couldn't get to them quickly enough, would just shut down hard as if someone pulled the plug, literally. And then getting them up again, getting the Zookeeper cluster to be reconciled, all of that just became a headache. So I kind of decided, okay, fine, we're not done with Zookeeper. Let's try something else. So then I thought, well, let's simplify things. If I'm running containers, I don't really need to manage the server, so let's just go with plain Docker run commands. Nice long commands, mount the volumes, all of those things, and then just ran it, which was great until, once again, the server dies. And in this case, it was a hard drive failure. So what happened is that my little container that had been running there for weeks and weeks and weeks was gone. So data is fine because I've got a RAID array that I'll show you in a little bit. But effectively, I couldn't remember how to launch the Docker container, so I had to go refigure things out. So I thought, okay, this is now crap. I'm not going to do this again. Let me do it properly. So I switched over to some Docker Compose files. This was nice. Just a simple YAML file. You configure your services in there, put them in a Git repo, shove them somewhere else, offsite, GitHub. Then you can easily fix things. And then after a while, I got annoyed because I had to change it and editing the file, then running Docker Compose and running it in multiples of them the whole time, up and down, really got me annoyed because I didn't want to keep running these commands. So finally I decided, stuff that, let me just use Terraform. And that was also a bit after ECS Anywhere came out. So I decided, well, let's give this a go and see how it's going. And it's now been a few months and I'm super happy with the setup. It just runs, doesn't break so far, at least, unless I break it. And really, really happy. So we spoke about data and data safety. So what I have in my little server over here is I've got four terabyte drives in there that I'm running in RAID 5 using MD80M RAID. Now, the nice part here is that I recently reinstalled the server about 2 weeks ago because of the OS drive failing. And the new versions of Ubuntu just automatically picked up my array. All of that I had to do was add it to etc fstab to make sure that it obviously mounts to the right folder that I want. But it already picked up the actual array, so I don't have to worry about my data, obviously, unless one of the drives fails. That's a whole other story. But basically, that's how I do my data safety. Everything sits on the array, including my Terraform files that I also have backed up, pushed up to GitHub. But everything on the OS drive I consider as things I don't care about, because if something happens, I replace the drive or just nuke the operating system if I make a mistake somewhere, and that's how we go forward. So first question for the talk tonight is quickly, what is traffic? And don't worry, I'm not going to read this whole slide. This is the official definition on their website. You can see the link at the bottom. But the part that I really like about this is that traffic is designed to be as simple as possible to operate, which is important to me because I really do not want anything complex at home. I really want to dumb things down as much as possible because I don't have a lot of time to play with it and spend it. I've got two very young kids, so most of my time is spent with them. But basically, I've played with traffic in previous roles a couple of times, and so I thought, well, let's use it. It seems simple. It's a single binary. I can just run it. And the configuration is super simple. So to have to work with Docker, all you need to do in the traffic TOML configuration file is these two. Firstly, you tell it what's your entry point, which in this case is port 80. And then if you wanted to auto-discover services running, there are various ways of doing it. So I started off with saying, well, go look at Docker running on the host, and off you go. And that was actually nice because it automatically picked up the containers and it saw them, but I couldn't get any traffic to them. So the first thing that took me a little while to figure out is like, how do I tell traffic what URL to send to these specific containers? And it ended up being that there are a couple of ways you can do it. You can do it in the config file, or you can do it dynamically by specifying specific Docker labels. So what you can see over here is that I've got a container using SmokePing running, and I'm setting up those 4 rules, and we will dig into it a little bit more. But basically, the first one is you just give it a host to actually use, which in my case is pings.cobus.io. And then I tell it that I want TLS. This we're going to cover in a little bit now, because I want it to run over HTTPS. And then also I tell it what cert resolver to use, because it's able to use multiple different ones, but I just chose Let's Encrypt. And then lastly, I provided with what port on the container to actually use to forward the traffic to. Now that last line, the port, you don't specifically have to have on the container unless the container has more than one port exposed. If it does, it'll just grab the first one. So if you have, let's say, something that exposes 3 or 4 ports, and you want the actual web interface to go to not the primary port, then you have to specify that. So that's one thing to keep in mind. And the reason I chose traffic as well is that I wanted to be able to easily get to my servers. And by easily, I meant that I didn't want to deal with these screens. So we've all seen these where you install some kind of software package, it self-signs an Ssl Certificates, installs it on the web server locally, and every time you open it up in your browser, it says, this is not secure, do you want to go? And you have to go click advanced, okay, go forward, or import the cert. It's just annoying. I didn't feel like doing that the whole time. So Traffic's able to handle HTTPS redirects for you, and it can do that using Let's Encrypt. So to do that, what you need to do is you need to add a little bit more config to your Traffic instance, which is just to tell it, instead of just having the HTTP port 80 entry point, you also say, well, there's going to be another entry point, which is web secure, not just plain web, which is how it knows how to do HTTPS. And then what you also do in there is, you can see there on the fourth line, is that I do a redirect, because I don't want someone accidentally putting or accessing the site, in this case, the only someone is me, and going over HTTP instead of HTTPS. So Traffic actually automatically handles that whole redirect to HTTPS for you. So that seems fairly simple. That's not too hard. Now, I want to get some Ssl certificates, because otherwise I'm just going to have the same issue once again. So all you do for that is to enable Let's Encrypt. You add a little block that says, well, here's a certificate resolver, some configuration. Basically, that email is just one that needs to be reachable in case they send you information or they verify it. I can't exactly remember what I needed that email for, but I know they asked for one. And as you can see over here, what I'm telling it is that I'm using Route 53 as the provider to for the DNS challenge, because how Let's Encrypt works is that there's some form of challenge. There are a couple of ways to validate you actually own the domain that you want to search for before they're going to issue you the cert. Because as you can imagine, if you just request it for any other random domain, that might cause some problems and be some security issues. So you have to do that. So we're going to get into the Route 53 configuration as well, but basically this is it on the configuration side for Let's Encrypt. Nothing too hardcore. The one thing that I did have an issue with is with those self-signed certificates, which is you have to add this one set of config inside Traffic's config as well, to tell it to ignore those insecure certificates. Because otherwise what happens is when it tries to forward the request, it's going to say, well, oh, hold on a second, I don't know who this downstream provider's Ssl certificate provider is, because, or certificate authority is. I don't know it, I don't trust it, I'm not going to send your request through. So that's why you need to add just that little bit. So this is one of the first things that happened. So now we mentioned that Traffic is going to use Amazon Route 53 to do the DNS as well as the DNS validation for the certs. But how is it going to do that without any API credentials? So once again, we're not going to start off with version 1. Version 1 was very, very simple, very effective, and not very elegant. And what that was is that I went into my host, installed AWS CLI, configured it with credentials, and then just mounted the volume into the actual container. It worked. Not necessarily the best thing to do. And just to clarify quickly here, I'm running Traffic inside a container itself as well, because I don't want to start installing things on the system. My whole point behind this process was, can I get to a point where everything on the system is in containers and I don't need to worry about anything? So this was version 1, but I at least did the proper IAM configuration, which is create a policy that only allows very specific access for Traffic to my AWS account. And what you can see over here is that basically it's allowed to list the host zones as well as the host record sets, and it's allowed to change the record sets only. That's the only thing it's allowed to change. And it could also request the get change just to see if it's gone through already. And then the second policy that's attached to it is this one, which is it's allowed to do a list hosted zones by name. So it can actually see, well, you know, whatever domain you specify, does it actually exist in it? And that's it. That's all the permissions it needs. So this was great. Started running all my containers. And as mentioned in the abstract of this talk, I ran my Pi-hole on this cluster as well. Great idea. Except, once again, if you haven't run into this, you will at some point in your career, it's almost guaranteed. DNS is often a single point of failure. So what happened here? Basically, I ran Pi-hole inside this cluster on this specific server, and I made some configuration mistakes, and then I didn't realize that I broke something on Pi-hole. I can't remember if it was the port forwarding or something, but in any case, I broke it. So what ended up happening is that everything in our house was down, people unhappy, daddy was less loved, and so I thought, okay, cool, let me solve this and do it in an easy way that I don't have to worry about DNS if I do want to fiddle with this cluster, because this is my play cluster. I play here, I try things, I break things. So what I did is I took Pi-hole and installed it on a little Raspberry Pi on the side. Now that obviously is not on the same host as this server running Docker, which means that Traffic has no idea about that service and how do I get my nice HTTPS URL to point to that service. Well, for that, what you do is you can actually create some additional routes that you're effective. They're called dynamic because this is just the documentation refers to it as dynamic. So I'm assuming there's services that can update this file as we go along. But in my case, these are actually very, very static. But this just tells traffic, hey, there are additional services that you need to expose. So similar to those Docker labels that we had to explain to traffic what the DNS name is to use, or the host name is to use, and also what port and all that, you define it in this TOML file. And basically, I've got two sets of configs in there, one for my Pi-hole and one for my Unify controller, because I run some Ubiquiti networking hardware at home. Same story is that my Unify controller is on its own Raspberry Pi. But once again, isolation, failure modes, not worrying about if my server goes down, my entire Unify setup, I can't access or make changes or fix it. So that's what I've got there. So basically what we're doing here is we define a new load balanced service, and then we tell it which servers to use. Now you can specify multiple servers in that list, and it'll do a round robin between them and actually send the request there. But in this case, you can see that my Pi-hole is running on 5.8 on port 80, and my Unify controller is running on 5.12 and it's port 8443. So that's the one that has that insecure SSL or self-signed SSL certificate that we had an issue with. And then below this, what you do is you just give it the actual detail for the routers. And this is now the routing rule. So I say, well, send pi-hole.cobus.io there. The entry point is web secure because I only want to allow HTTPS traffic to there. And that's it. So then what I started doing is, like, we now got to, sorry, just give me a sec. I think I messed up my slide order. Yes. Come on. Yes, sorry. I dragged that one, and here we do live slide editing from current slide. There we go. Apologies about that. So we interrupt your own story. And as you can see, there is the Pi-hole one that shows the Pi-hole DNS, and then also just says which service it maps, because you've got this concept of, similar to if you've used Kubernetes before, we've got the pod or the deployment, and then you expose it as a service and then add an ingress rule to it. So in this case, what happened is that I don't need the ingress rule because that's just DNS being configured. And I could define the service actually in the previous section. And then I say, okay, well, this specific routing rule applies to that service. And then that's how we route the traffic back and forth. And you can see it's very similar for the Unify container. So then we start playing with ECS Anywhere. And this is now slightly different in terms of configuring your container to run. But if you've ever run anything on ECS before, there are two basic building blocks for it. The one is the task definition, which is similar to your, let's say, Docker Compose file, or where you define what container you want to run, what's the variables, mount volumes, all of the things associated with the container itself. Then you create a service, which you say, use that task definition, and then say, I want 3 copies of it, and I want to schedule over here, and then let's launch it. Then with ECS Anywhere, there's only one small change. Everything else is basically the same. And that last change is this launch type. So there are 3 launch types with ECS that you can use. It's either EC2, where you have an EC2 host that you have the agent running on, and it'll use that to actually schedule it. Or you can use Fargate, which is a serverless way of running a container, where basically you say, Fargate, here's the container, give it 2 CPUs, 2 gigs of RAM, go run it, and you don't worry about the host. It provisions it in the background, runs it, keeps it up to date, everything for you. And then the third one now is with ECS Anywhere is this external type. So what I'm telling ECS here is that for this service, I've got the task definition. Now please go run this on an external node in the cluster. Not that that exists yet. We'll show you how to create that. And then the same with the actual task definition. I tell it, well, this one requires the compatibility external. So in the task definition, you specify where can this set of configurations be run. So you can change this to be multiple ones. So you can also run it, let's say, on Fargate if you want to. The problem there will be with the mount volumes, because guess what? I'm running these on my home server. There's a specific directory on the RAID array with the configs and data that I want mounted into them. And if I took that as is and ran it inside or on Fargate, it wouldn't be able to mount the volumes because they don't exist on the host in the background. So let's simplify things a little bit. Basically what happened is with my switch from using Mesos running on 3 of these little mini servers into a single one, what also happened along the way is that I realized that I don't really need 3 machines. It's very nice to play with. It makes me happy, but it requires maintenance. It breaks. So I started to simplify things. So what it is, I upgraded to the next generation of these servers. And I apologize for the state of that server. When I open it up before this talk to take a picture, it has been the first time in probably 3 years I opened it. So I try to get some of the dust out of the way. But yeah, I need to give it a good clean. Sorry about that. But basically, same idea, just a slightly newer generation. This one's got a nice i3 processor, and I think it's got about 12 gigs of RAM at the moment. And it just runs. It's been running for literally years without maintenance. And it's on permanently. It's actually behind me here on the desk. So we're going to dive into the console after I just cover some of the things that I learned, and then I'll show you the exact setup, where the config files live, what they have in them, and how everything actually combines in together. So things that I learned. The first one is don't use host mode networking on Docker, because what happens there is the whole point of using multiple containers is not to have to deal with those port clashes. Like if you fire up 2 different containers, both need port 80, in host mode, that'll clash. The second one launch will not work. So use the normal bridge networking mode. Traffic actually handles that quite nicely for you, which is the first thing that I bumped my head against. The second one is the one that I'm still a little bit annoyed about. I was actually thinking about trying to patch traffic to fix this for me, which is traffic is the concept of connecting with multiple different sources of where the service is running. So Docker is one of them, ECS is one of them, Kubernetes is one of them, Mesos is one of them, Docker Swarm. You can basically, there's a very long list of how I can figure out where those containers are running. The problem, however, is that ECS Anywhere, while the main ECS API calls are the same, there's one small difference, and that is the actual instance ID, and also the API call you need for that. Because there's a difference between a, let's say, EC2 instance running on inside AWS versus the one here, running here locally in my room. And the problem there is that the instance ID starts with MI instead of the usual, I think it's I dash. And the second problem is that the describe call used to get the information is different to the normal EC2 one, which means that when traffic tried to do that lookup, it actually breaks. It's just broken. It's annoying. I'm hoping to fix it, but it is open source software. I can probably go patch it if I really want to, or just wait a little bit for it to get fixed. Then another thing that I'm busy playing around with is I added a little 1030 GeForce GPU because I want to try using it to be able to encode some video files for me for when I do it. Literally just because I want to try it out. I want to see if I can get a container up and running and throw some transcoding over the network to it to actually do it. It's going to be slower than my desktop, but this is literally just me playing and having fun. The important part here is that when you register your instance, and we're going to show you how to do that now in the console, is that you need to add a little flag or parameter afterwards that says # enable GPU. Otherwise, you cannot use that. This is, however, a very, very recent feature. I think it launched 2 weeks or 3 weeks ago. It's still very, very new. But I'm still trying to get that working. That's something that I'm busy playing with. Then, if you have played with ECS on instances, this one drove me nuts for a while. Because what I did is I would register the server, get it working with ECS, then I'd say, okay, cool, let me delete everything, restart it because I want to try something else a little bit, and then it wouldn't register because it said, no, this instance is already registered with with ECS. And it took me a bit of a while, and I realized there's this folder called envarlib ECS that actually has the database file for the ECS agent where it keeps track of what's going on in communication with the server that you have to delete. So if you want to re-register an instance, delete that file. Otherwise, it's going to cause some issues.
Hey.
Yeah,
Cobus, let me ask you about that because I know you're really talking about traffic, and since I'm an ambassador and I worked a lot with them, I'm curious about this stuff about ECS. Because yes. I know they did a lot of improvement on ECS, especially in the last version. Did you still find this problem with the last release of traffic, or is something you didn't update with the last things, with the last provider updates?
No. So the last time I tried this was probably, I'd say, a month and a half or 2 months ago, if I remember correctly. That's the last time I tried.
So you should also be the last version.
Okay.
I don't know. We should. I will check it after, and I will give you some feedback because I know that ECS was something they had to work on for a little while because it's not so easy to be, you know. providing everything.
I was also a bad internet citizen. I didn't go file a GitHub issue on this. I'll go check if there is one already and add some in, or add one if there isn't. But it literally just boils down to it's the API call that's an issue, because the instance ID is different and you need to use a different describe call.
I understand.
Yeah.
Okay, cool. Go on.
Awesome.
Thank you.
No worries. Then the other one that was very interesting for me was that how ECS Anywhere handles network failure. Now, if you're running inside AWS, there's a certain amount of, there will always be network partitions, but there's at least a certain understanding of what is the latency like, how often do things, let's say the ECS backplane disconnect from the actual ECS agent, the expected duration of that and all that. But with ECS Anywhere, given that the backplane is running inside AWS and the actual agent is running here on your home network, and let's face it, home networks go down, power goes out, someone pulls out a cable, something happens. What happens to the services? And this I found super fascinating, because when I took a step back and thought about it, it's like, this is actually smart, which is it leaves the services running. It doesn't try and reschedule them, because the assumption here is that the services, when it loses connection, that the services are still up and running. It doesn't want to reschedule them. There are obviously ways you can say, listen, react to it if you want to handle that, but basically it'll stay up running. So I can go pull out the network cable, wait for however long I want, plug it in again, and then when the ECS agent connects back with ECS, the backplane, then it'll say, cool, let's quickly reconcile your view of the world, my view of the world. Did someone schedule any new containers, or did I lose some containers or something? And then ultimately it'll reconcile and only make changes if it needs to. It doesn't have to. Then we already covered this one, which is the little gotcha with traffic and self-signed Ssl certificates, which did cause me a bit of headache. Took quite a while just to know what to Google for to actually fix that one. And this was also a little bit of a block for me. So like I said before, I'm running traffic inside a container. Now, when I switched over to using ECS Anywhere, that gives me the ability to inject an IAM role into each one of these containers one by one. I don't have to worry about giving the sum total of permissions to all of the containers. I can specify individual IAM roles to them, which is great. So I created the IAM role that gave traffic the appropriate access. However, my setup is a little bit more complicated than your standard setup. I typically use anything between 3 and 7 AWS accounts for a default setup. For example, I have one AWS account just for my DNS registrar details. So I register domains in that account, and that is the only thing that happens in that account. Nothing else is completely walled off from my other accounts, and I don't generally go in there unless I want to register a domain. Then I've got a second domain that is actually, a second AWS account that I use just for DNS, just to keep things simple, so I know that the DNS always lives there. And then I've got some accounts that I play with. So what I wanted ideally to do is to have traffic reach out to the DNS inside the one account to actually register it, but then run the cluster itself. The underlying cluster would be in another AWS as well. But the cross-account roles there, I'm still going to play out and see if I can't do the role switching in there or assume role inside it. But I got a point where it wasn't quite working, so I said, okay, well, for now, let me just run the cluster inside the same account as DNS for now, but I'm going to fix it in the future. So that's one of the things that I also got. So future plans quickly. What I want to do is that I definitely want to add more servers. I definitely want to start having multiple traffic instances running as well, so I can really spread my containers around, so that if one host does go down properly, I can just say, well, remove it from ECS cluster, go schedule it everywhere else, and everything is then fixed. So that's kind of what I want to do. Then I also want to play around a bit more with, get a couple more containers and services up and running. I've seen some very nice things from Jeff Girling, I think is how you pronounce it. He does a lot of Raspberry Pi, little home projects, home automation. He's got one with a nice CO2 sensor that I want to run and actually integrate with home assistants, etc. But basically, I just want to spread the warrior across multiple servers again, just because I want my cluster back. I feel like I lost a friend when the cluster went away. But that's that. So now what we're going to do is we are quickly going to jump into the console and my code, so I can actually show you how all of this works, because that's the fun part. It's we're done with all the talking for now. So first up, everything I have is being run is being created using Terraform. So on the left here, you can see the files that I have over here. I've got a couple of different domains in here. I still need to split this out. Might not. Depends. It's a home project. I don't want to spend too much effort on it. But starting from the top, my providers, My Terraform is configured to have 3 different AWS providers to jump between the different AWS accounts. So you can see there's the main root account, then I've got my DNS account, and then I've got my personal account, and they run in specific regions. And you'll see the profile here is which AWS CLI credential set to use. So the way I've got my credential set up is there's only one credential set for my top level account, and then I use role switching inside that config between all of the different accounts, and Terraform just reads it from there and uses it. So from a credential perspective, I don't have to worry about this. Worst case, I need to reconfigure that file, and that's fairly easy for me. Then I have it set up to use where's my state file? There we go. To use S3 as a state file. S3 as a backend for my state file, just so that every time I make a change, it stores the state file in S3 so I can run it on multiple machines. And now for the actual fun here. So what I've got is if I go to the DNS itself over here. So this is just, you can see there's a Route 53 DNS zone configured, and I just specify the provider because by default it assumes the first AWS provider or non-named provider to use. So in my case, I've got multiple, so this needs to go into the DNS account. So I just specify that. And I just say, well, this is the Cobus.io domain. And then what I do is I've got my Google Apps mail set up there, nothing too exciting over there, text record for SPF, DKIM setup, etc. And this is where the fun starts. So this is just pointing the www.cobus.io to a CloudFront distribution where my static website is hosted. Also not too interesting. And this is where I started off with the first set of DNS. My first attempt is that I had a long list over here of DNS of the different services that I have. They all point to the same host, which is 192. Where's it? Over here, 5.5. And I just loop over them and say, listen, go create all of those. And the reason I don't do that anymore is like as I add services and remove them, I sometimes found that I might have name clashes and deleting DNS records and things. So I stopped using that. And instead what I do now is that for every container/service that I launch, I include the DNS at the top, then the actual ECS task, and then the task definition, and then the ECS service to actually get it going. So that's the old way of
Sorry, Cobus, to interrupt you.
Yeah.
May I ask you, because we exchanged some links before, but I think that I don't have the exact repo for this one. Is it reachable so people can follow you in code or something?
This repo, no.
Okay.
Yeah, there's nothing particularly secret in here. It's just that this repo is my personal setup at home, so it's not something that I feel I should be putting on the internet. But there's, like I said, there's nothing funny in here in terms of like secrets or passwords or things. What I'll do is I'll create a clean version of this tomorrow and then send you the link so you can post it in the meetup group.
Exactly.
To play around
Okay, no problem. Cool. No problem at all. Thank you.
Awesome. So then I've got the IAM role for the cert bot that I created, or the user. This was because why did I create this again? I remember. I was trying to play on to get it to work via the CLI, and I needed a user instead of a role for it for a while. So now for the actual services, what I've done is that I've got this container vars or variables file where I specify the amount of memory, because at the end of the day, you still have to manage some of the config values, and I got tired of having to tweak the memory values between the different ones and jumping between multiple files just to get everything to fit on the server. So this is basically just the container memory. So we just do a map lookup when we actually specify it. So let's go look at one of my containers. This is for Home Assistant, which allows you to automate a whole bunch of things at home. I've got a number of Zigbee temperature sensors that I use. I've got motion sensors that I'm playing with. So basically, it just aggregates all the data, and I get to play around with that. So what you need to do to get that up and running first is set up a Route 53 record so that when I go to home.cobus.io, it'll hit this IP address. Now, you'll notice here that everything goes to this single IP address because that's where traffic is actually running as a reverse proxy. So everything just goes there. It's a bit boring. I could probably use a wildcard. I just haven't thought about it properly yet, but that could also work. Then what I do is I configure the ECS service. As you can see over here, it's nothing funny. It's basically you give it a name. You tell it what cluster to access, which is the one we created. Where did I create my cluster? I actually need to go look. Oh, it's probably here. can't remember which file my cluster is. That would be funny. Come on. Home containers. Here we go. Sorry. So here is the cluster that I'm using, which, as you can see, you give it a name. That's it. That's how easy it is to get ECS cluster up and running. So now what I'm doing is, where to go? There we go. I've got that cluster that I'm using, and then I tell it what task definition to use, and also how many copies I want running, and also that one thing that I spoke about, which is the launch type, which is external. Now, this is what the task definition looks like. You once again give it a name. Family is just to group the actual task definitions together. I did say that it needs external compatibility, and then I just do the task definition, which is how much CPU, is it essential? So if you specify more than one container, if one of those containers is down, should this entire task be down or not, is basically what you're saying here. Because you might not worry if certain containers in a single set go down, but if this one, for example, goes down and it's the only one, I'm not going to be happy. So restart it if that happens. Then also just the container image, how much memory to give it using that map lookup, those Docker labels I spoke about earlier, then passing it a couple of values over here. And yes, I am aware that I should not be using the root user inside Docker. I need to just spend some time and clean this up and run it properly as a non-privileged root user. Or non-root user. So I'll go fix that at some point as well. And then it's just the mount points. The only difference here from typical Docker configuration is you would specify the actual host path and then inside the container path, where with ECS task definitions, you split it into two. So what you do is actually at the bottom, what you'll see is, here, is that here I say there's a volume definition. This is the name, and this is the actual mount on the drive on this machine. So then I take that name over there, and then when I do the mount over here, you can see that I say source volume is that name that I had down there, and this is how to mount it inside the actual container for us. And that I've done with all of the other ones, CAdvisor, I've got Grafana. I did go kill off Prometheus just to quickly demonstrate how this works. So if I open up this tab, if I go to prom.cobus, we can see that it's not running. If I go, come on, I hope I wasn't logged out now. It shouldn't be logged out. There we go. All good. I can see there is no entry for Prometheus over here at the moment. And also looking at the traffic dashboard, there is no Prometheus in here. So we are good. I hopefully killed it off properly. So I just need to rename this file again, because Terraform ignores any file that isn't or doesn't end with .tf. So now I can go Terraform apply and be a little bit, what do you call it, unsafe, because you should run a plan, check the output first, and then say apply with the output that you generated. Otherwise, things might change under your feet. Would not recommend that. And basically what it's running now is this is running off my machine here, so it's slightly slow. And what it wants to do is it wants to create the following. Let's just scroll up. So it'll create a ECS service, Prometheus, with that cluster that I have, some deployment percentages that if anybody is interested, just raise your hand and let me know if you want to dig into how that works. The desired count, and then that external, which is important over there. Then the actual task definition that you need to know how to run the container. You can see over here all the different values, the bound points, etc. And then lastly, it's going to create the root 53 access for me. So now let's go ahead and say, let's create that. And this will take probably about, I think, 30 to 40 seconds. So, okay, cool. So the ECS service is done, task definition is done. And now we are probably just going to wait for DNS, because we always wait for DNS. Let's refresh here. Let's see if, there we go. So the DNS record is already there. I think it's just waiting for it to validate. Like I said, this normally takes about 40 seconds, at least with Terraform, because what Terraform does is it polls. So it'll poll 10 seconds, poll 10 seconds. And the funny thing here is if this was a laptop and I closed the lid and went off and open it up again, it actually just continues where it was going, because it'll just continue with the polling. I did that once. I was very surprised when it said, well, 4 hours later, resource created, where in actual fact, obviously, it was a bit quicker. So now that's done. So let's see if we can actually see this now. This is always the fun part. Will it work? No, I don't think it's resolved yet. We can try our luck, but I doubt it. Okay, so now we just need to wait for that to actually propagate, which will take a while. But let's see if we can actually see this now. This is always the fun part. Will it work? No, I don't think it's resolved yet. We can try our luck, but I doubt it. Okay, so now we just need to wait for that to actually propagate, which will take a while. But let's see if we can actually see this now. while that is going.
So, Cobus, let me
Yes.
see if we understood correctly. So, what is Terraform doing is creating an entry into the Route 53 zone, and then it
Yes.
will spin up the service with the given DNS reference.
Yes.
Okay.
So basically what happened now is if we look down here, we can see that it's Prometheus is not here because I refreshed it 15 minutes ago last. And now if I click, we can see...
There it is, the Prometheus.
There we go. That one it is. It's up and running. I can see the actual tasks. Because remember, the service is the container for the actual number of tasks that you're running. And we can see over here that it is running. And we can even check it. Where's this one? Sorry, I forgot. Like I said, I still have to set up this user to be allowed to use Docker. Come on. I'm tight under pressure. Cool. There's Prometheus. You can see 2 minutes ago. And it's also the latency between, as soon as you send the service request to ECS, it actually spins up like within seconds. It's, well, with obviously how fast your home connection is to pull the image, because it still needs to get the image from somewhere, but it's really quick. But basically, the overall setup, if you want to get this going, consists of that bit of Terraform that I showed you. So having your DNS managed and creating the ECS task definition, the ECS service with a cluster, and then just the DNS entry to point to it. And then also you need traffic, which I haven't showed you yet. Was my code? Here's traffic. Similar traffic's just got a, I call it a monitor that hits that same IP, same story. There's a service, there's a task definition. What I did over here is that because this one has got an IAM role, and you can see over there, there's the IAM role that I pass in. I just say depends on that so I can make sure that there isn't a dependency issue in terms of like trying to create the service before the policies have been created. Okay. And then once again in here, nothing really funny, just normal traffic configuration with the standard config and the dynamic config. And I just give it this value because there was some issue with DNS with traffic where with Docker and bridge mode, it didn't quite figure out where the DNS was. So this was one way just to get around that DNS issue. And that's pretty much it over here. And here you can see the actual policy for the certbot, which is that one I spoke about earlier. It allows the rule changes, Route 53. It still has the ECS read permissions in here because I'm still trying to get that going, which is why you see it over here. But if you don't want to use ECS, you don't need to. Then this is just, this is still me trying to get the ECS task running. And this is just the IAM role for the external instance as well that I'm playing around with. What else I have here? These ones you can ignore. This is this is just attaching the individual policies to that specific role that I had.
How hard was achieving a working DNS challenge in traffic? Because I want people that is listening to us to fully understand that traffic proxy is a very nice and easy and a very low level, very low entry level, very low barrier to enter, to learn. The curve is very flat. But on the other side, when you start dealing with SSL, so I would advise wait that your service works without SSL and then deal with that, because otherwise it becomes more or less a nightmare. So I'm curious how was easy to have a DNS challenge with all this complex configuration, if it worked out of the box or.
No, it was, in the end, it's like with any new piece of software, there were a couple of concepts I needed to understand, like what's the relationship between a service and a routing rule. But once I figured that out, it's extremely simple. Like I showed, let me show you the code in total for, which one is this? Home Assistant. So literally the traffic portion is those four labels that you add, which is the rule, the TLS, to which TLS resolver and what port. And the port, like I said, is optional if you've only got one port exposed. That's it from the Docker perspective. Then for traffic itself, if we actually go look at the actual details, 92 configs, traffic, here we go. Yeah. So this is the entire traffic config file. And what you can see over here is that's where they say the entry points,
Yes.
HTTPS and HTTP, that cert invalidation, expose the dashboard, set up root 53, and once again, let's encrypt with root 53. This is the entire setup of how does it validate itself. This is all you need to do, which is super cool because it's literally this plus that IAM policy and you get it running. And then basically here at the bottom, I just tell it that use Docker as well as that dynamic file that I'm using. And that was it. I mean, that gets most of the stuff running. And then if you want to actually look at the static definitions, this is where all my static definitions are for the Pile and the Unify controller. And at the moment, there's just that one routing rule you have to put in for the monitor for that dashboard that I showed you in the browser, and that's it. I mean, in terms of simplicity, this makes me super happy. This was literally like, I think it took me about an hour or two just to figure out everything and get it up and running and then play around with it, and then it just worked. I mean, I haven't had to touch it ever since, and I don't think it's crashed once.
So basically, the DNS challenge was easily solved because with IAM role were set it up correctly, and the DNS challenge or root 53, that's it, and it works.
Yeah.
Nice.
And I must say, I must confess, I don't even know how the challenge works because I didn't have to. It just worked.
Exactly.
That's the thing. So that's the beauty now.
Yeah. Nice thing.
Let's actually see if this one is up now because it's. Let's see if I do a hard refresh. Come on. No, it's not loading yet. That it's up and running. If we look over here, oops, I think I dropped off. We can see that Prometheus is now up here as well. And this is literally the little dashboard for traffic that you can see. You can see this little line at the top where it refreshes. And you can go inspect any of the services if you go to the main dashboard like that. You can see all the different things. I've got routing rules, services, and I only have one middleware, which is the HTTPS redirect that I've got in place. Sorry, not the HTTP redirect, using the Let's Encrypt for HTTPS certificates is the only middleware I have in place. And the reason there's a difference between routers and services is that I don't have a routing rule, I think, for the actual API for traffic. But basically, you can see here, you can click on one of these, you can see the details, the URL inside, or the IP and the port for Docker that it's using. You can see it's provided by Docker, currently happy. If I look at something like, for example, where is Unify? You can see here that the icon is different because this is specified by a config file. You can see over here, it says provider file. So that's it. The last little bits that I want to show you quickly is how you add your server to ECS to actually use it for capacity. And that's also quite easy, which is you go to your, okay, let's just refresh. There we go. Sorry, double refreshed. This is now my cluster home. And we can see over here, it says ECS instances. And I've got my little home server running here at the moment. So if I want to get a new server, all I do is I say registers the external instances. And then on this next step, I'm hesitant to show it on screen because it will allow someone to register on my AWS account and potentially get some containers running, which I don't want to do. I'll risk it and figure out how to cancel that very quickly after this. So basically, what you do is it gives you a little curl command like this. And you copy and paste this and run this on your little server. And then what it does is it checks if Docker is installed. If not, it installs it. Then it installs the SSM agent, which is the Simple Services Manager agent, or sorry, System Services Manager agent. And then lastly, it installs the ECS agent. Now, I actually had a server failure recently, and it took me under an hour to set everything back up again because all I needed to do was install the latest version of Ubuntu Server, then mount my RAID array, and then install Docker, change the data directory because I have Docker's data directory on the RAID array as well, and then run that script. And it was back up and running. Containers popped up over the next 2-3 minutes, and I didn't have to worry. So in terms of a home setup for low maintenance, fun to work with, and kind of easy, I'd recommend this. I'm still enjoying it. I'm still tweaking it, but it's been a lot of fun so far. So, Sergio, I think this is the point where we have some discussions and some questions. If there are any.
But let me ask you. What you actually, with this configuration, what you actually achieved so far? What is the final configuration? What do you use this for in your, you use it at home
Oh,
or you handle?
yeah. So what I use it for at home is at the moment, basically the main use is that home assistant. So
Okay.
like I said, I'm playing with temperature sensors. I've got little infrared
Mhm.
transmitters as well. So I'm trying to control the air cons for the kids' rooms so that, let's say at night, for some reason it gets cold and we didn't check the weather beforehand, it automatically switches on the heater or switches
Okay.
on the aircon for them. That's kind of automation that I'm busy playing with. And then obviously Prometheus and Grafana, I want to get a dashboard up to also show some other data when I add some other sensors like some CO2 sensors, weather sensors, who knows? It's just playing. And then obviously C Advisor and Node Exporter to get the stats out of the containers to see how they're performing. Because I want to build a proper dashboard so I can pretend this is a network center and I have many servers.
Do you mean to control like remote or something like that, or is something like more private at your house?
The idea long term is to be able to connect to it remotely because with the SSM agent running on the server, I can SSH to it using the AWS console, which means I don't have to have a VPN. Then, obviously, if I want to access the specific services, I would need a VPN unless I do a tunnel through the actual SSH connection because you can do that, which is it's weird in the sense that you can use the AWS CLI to SSH to a machine and port forward to your local host, which is it's a fun one, and you don't have any ports open to the outside world, but it works. It's obviously built in. It's just what the service provides. So the idea there is that I could get into the home network, look at things like the cameras, the switch on lights, manage the air cons on things. Because let's say it's a hot summer's day, we've been out for the day, and we are about to get home, and we want to put one of the kids down. Let me just start the aircon 5 minutes before we get home because
Okay.
trust me, that is a very big quality of life thing. A happy kid is awesome.
Yeah, yeah. But I have another question, but you have to be sincere. How long does it take to you to have a full working configuration of like that?
um, this probably with all the different parts. I mean, I didn't do it in one stint, so it's probably like a week's worth of tinkering in the evenings a bit to go from nothing to everything. Um, so yeah, I think about a week. If I let's say maybe 2 days if I spent the whole time on it, if I had to think about it.
Yeah, nice.
So
Because you know what? When I have this home project, there is a turning point when where nothing works. Literally, nothing works. So my question to for the audience is how to motivate in this sense. Because when nothing works like that, well, I mean, it's hard. It's hard to find if it's worthy or not.
mm. No. The point for me with that was I had the issue with traffic where it couldn't resolve DNS for some reason, which was just like, and it's a Docker thing, and I still need to go dig into exactly how that Docker DNS works, because
Is
obviously
the
I've got the
host
file.
internal you showed us before the extra host you showed?
Yeah, yeah. So that's the extra host I passed through the. Where was it now? It's in the traffic one. Here. Come now. Too much scrolling. There we go. That part, yeah, because it's something to do with because I've got the Pi hole running on a different server on the network, and my little MikroTik router actually sends that out as part of the DHCP options. The main server has got bindd running, and I think there's something where Docker assumes that the local bindd will do that lookup, and that local bindd isn't configured to forward the lookup to the address provided by the DHCP entry. So I still need to go dig into that a little bit more.
Ah, nice. But let me get into something more technical. What is according to you? Let's pretend you're not in AWS, but I don't want to deal with that. But let's say what is the real advantage you see on this setup of using ECS anywhere? Will it be possible to use something different? And or even, for example, if I want to do something more complex, EKS or something similar, And the second question is about the budget, because I had to do something that is a pet project or something I use home, and it should be working in terms of time, of working time, and in terms of economy. So how do you suggest deal with that?
Okay, so first question is the basically the reason I chose ECS for this is that I really want something simple. I know that I've only got a couple of containers running. I don't plan on doing a microservice architecture at this point, which means even though it supports it, I don't need that. So that kind of already excluded a whole bunch of things for me. So for example, I was looking at spinning up a small Kubernetes cluster using some Raspberry Pis as the primary nodes, and then have some worker nodes. But the amount of setup to get that up and running was just too much for I want to get a couple of containers up and running. The same with when I ran Mesos and Marathon. It's like it was great, it was fun, it was complex, it made me happy, but it broke every now and again. I didn't want to break. So that's why I chose whatever the simplest thing was. And like I said, I actually was fairly happy with just Docker Compose files. But it's just that editing and that workflow just got to me after a while. It's just like too much manual, repetitive steps there. And also remember the whole point of ECS Anywhere is that the idea is that you can run tasks this and containers this simply with hardware that you have. So let's say you've got a whole data center full of servers that aren't yet end of life. Install ECS Anywhere on them, and you can actually use them to run the containers. And then there are ways you can actually load balance across instances or copies of the containers running on instances or Fargate inside AWS as well, and slowly migrate them across. And there's some very funky things you can do with it. So definitely. And then with regards to a home project, I'm a little bit odd in the sense that I was a developer and then I went into DevOps and automation, which often it's the sysadmin side of the industry that tends to move towards DevOps. So I love this kind of tinkering, figuring it out, configuring it, testing 50 different permutations to see what works and what doesn't, and why it works and why it doesn't. So for me, this is a fun home project. And I think in terms of the overhead and complexity, this is probably not too much for a home project. Like I said, there are only 3 moving components. You've got ECS that needs to work with Docker, and then you've got traffic, and that's it.
And let me ask you furtherly, but I've seen that in your configuration of traffic, you have many file provider. For the ones that are listening to us, that means that there is something really static configured, maybe a static null service or something that is not exactly in Docker or whatever, exactly what you're showing. Is this why is it because of the nature of the service, or why you didn't decide to containerize this part? Wasn't it possible, or?
No, I can definitely containerize them. The reason at this point is that I don't have the ability to query these containers not running on the main host where ECS is running, because at the moment, because with that bug with traffic, or not bug, it's just an unimplemented feature due to the change in how ECS Anywhere works. Where if I could get it to do the lookup via ECS Anywhere, I would swap these out to be containers running on those 2 hosts and just use tags to say run this container just on that specific host.
Okay. So that's a matter of and not fully compliant with that. Okay, but I had another theory. So let me understand. We see you have a piece of hardware at home with very dusty, and I expected the post-it to not turn this off, but I didn't saw it, so I didn't see it. So I mean, but I'm interested in ask you further 2 questions. How much of this is running on this piece of hardware? And since you say there are probably blackouts happen quite often, or sometimes happens in South Africa, how does this configuration deal with that?
So I went this configuration is perfectly happy with that. If it's because the only thing I have to worry about is that my RAID array mustn't get damaged. And so far, touch wood, it hasn't had any issues. So worst case that happens is there might be some, let's say, data corruption if it was mid-write and the server just lost power. But what I did do is for my work machine, I actually got a fairly big UPS here in the room. And because the server is so low powered and it's just a laptop, I actually plugged the two into the same UPS. And it's able to last, at the moment, about 3 hours, and the power outage is about 2.5. So if I switch off the screens and unplug the laptop, then I know I'm fine. And so far, I haven't had issues with it shutting down. So it's been okay.
Okay. And which kind of piece of hardware would you suggest to bring on? I mean, someone would want to play. Is it possible to achieve something like that with a Raspberry Pi or
Mm,
some very small piece of the of device? I mean, I put $50 on the table and I can play with. Do you think it's
yeah.
feasible? All right.
It's I know it's feasible because we just finished off a talk for reInvent on how to use ECS anywhere on Raspberry Pis. So
Ah,
you can
nice.
definitely do that. There will be a talk that I won't be giving it. My twin Darko will be there to give that talk. But you can definitely do that. The only consideration that you have to make when you do that is just remember the image that you're running has a specific architecture on it. So you need to make sure that if you're pulling from a repo and it doesn't have multi-architecture in it yet, then you will run into issues because you can't run an x86 image on a ARM64 CPU. That'll break. But most of the what do you call it? Public containers have them. This one specific Linux server. They've actually got a lot of very good images, and they do multi-architecture. So I tend to normally go look there first for an image for a pet project before I do anything.
So let me ask you a question coming from the audience. It will be, they are asking if we can have there is some resources like a tutorial to achieve something like dead at home. And do you think it's feasible, or there is something links you can provide us in the future, or
Hmm.
I can post on the channel later on?
I think what I'll do is I'll do a little write up on this and do a public GitHub repo with all the code in it because that'll be the quickest way to get up and running with it. I'll obviously have to just fiddle a bit with the Terraform to make it so that I tokenize the DNS and a couple of things, but that's about it. So give me a week or two and I'll pop a blog post with the code for you.
Okay, nice one. So we will wait to hear you from the reInvent talk, so maybe we can wait both of them, so I can put some link to the
Hmm.
audience follow up. And if there is any other question? There is a question. Let me see that.
Oh, monthly price for setup on ECS anywhere. If I remember, it's I think $8.75 per host. So I know there's a cost associated, but for me, that's the price for not having to worry about this. So I'm quite happy, and it's on my personal one. It's not like I'm even getting discount from AWS for that.
But how would you balance how much is running on your personal host, or how much is running on the cloud in AWS? Is it something?
Yeah, you can do that because
Let me rephrase. Since you're running some of your own, the idea behind that is that you're running some of your own. Um, some of your own hardware and some hardware on the cloud. And how would you balance the things together, if I understand correctly? Oh, sorry if I.
so. No worries. So basically, it depends what you want to do. So, for example, obviously, I use Route 53 for the DNS, which is I think it's 50 cents per zone per month. So that's very cheap. And then, like I said, it's this $8. I think it's $8.75 last time I checked. Dollars, US dollars, per month for the link between ECS and the actual physical host. But in terms of what the host is and how many containers you run on it, there's no cost associated with that. It's a fixed per host cost. So if I had a big beefy server and I could run 50 containers on it, it would still cost the same.
Oh, okay, nice,
Yeah.
nice. So it's pretty predictable how much I can balance in advance.
Yeah. And I mean, the way I think about this is if I think back at my consulting days, what I would charge customers an hour to fix things versus how much time this saves you. I'm like, that, let's say $9 rounded up is, I don't even have to think about that. It's just like, no, it just works.
And probably at some point when the thing is becoming too big, maybe it's worth it to run on the cloud everything and don't have to worry about PC of hardware at home that could fail or whatever. Is it?
Yeah, the only challenge there is how to get the sensor data for all the sensors that I have in my house up to the cloud then.
Right.
Yeah.
So it depends on the context you're running it on.
Plus,
Okay.
I'm a server hugger. I love having servers at home, so I will always have them.
So you have UPS backups and then everything, disaster recovering scenarios and whatever.
Yep. No, I mean, I've got a 24-port switch. I've got two of these servers and one of the previous gens, multiple Raspberry Pis. So yeah, it's fun. That's my hobby.
So we will forgive you for putting pineapple on pizza because this is not allowed at this meetup, but we're making an exception for you, Cobus.
Thank you.
So I hope we can have you together again here in the future, and I hope you could come in Italy to have the real pizza, not the one with pineapple, which you shouldn't even call pizza. But I always have this very long joke with people around abroad from Italy. So thank you for joining us. Thank you for the audience to listening to this awesome talk by Cobus. And Cobus, as soon as you will follow up with the links or the tutorial or the repo, whatever, I will forward to the audience of the meetup. Thank you. Thank you to AWS for having letting you participating here, and thank you CNCF. And I hope you all the best.
Cool.
See you. We're closing. Bye. Ciao, ciao.